In this video, we take a look at ACES in V-Ray for 3ds Max. In the first part, I give you a quick introduction to ACES and how to set it up properly in V-Ray 5. Then in the second part, we'll learn why ACES is the superior color management solution with a few comparative examples. And in the last part of the video, we'll learn how to export ACES renders properly and how to handle ACES managed renders in post using Fusion. So let's get started. Hey folks, welcome to Mograph Plus. This video is a free sample from our course V-Ray 5 Masterclass, your complete guide to V-Ray for 3ds Max. It's a massive 15+ hours course in which we explore all the aspects of V-Ray for 3ds Max thoroughly. Make sure to check it out. The link is in the description. Also be sure to subscribe and ring the bell to get notified about our latest videos. So ACES is a system of color spaces and color management solution that through a set of mathematical specifications and guidelines allows for a fully encompassing color accurate workflow with seamless interchange of high quality images and textures regardless of the source. That is a very loose definition of what ACES is, and it has certain advantages when you implement it in your CGI rendering workflow, like being able to use a much wider and brighter and saturated ranges of color and lights without having to deal with burnout highlights and inaccurate colors, or simply put, it's very good at preserving highlights, shadows, and colors. It has a beautiful filmic response curve, a much wider color gamut, which makes it perfect for archiving and much more. Now, how to get ACES working in V-Ray? First, you need to download OpenColor.io or OCIO configuration from GitHub. Just Google OpenColor.io configs and the first index should be what you need to get. Then simply click on this download button and extract the downloaded archive somewhere safe on your storage. In there you will find different version of ACES, and we work with the latest one, which is 103. First, we need to tell V-Ray we want to use ACES as our color management solution and give V-Ray the path to this config.ocio file within the ACES 103 folder. To do that, let's open up the render setup window and go to the settings tab and change the color space from sRGB to ACES and enable this auto RGB primaries for V-Ray bitmap texture. I tell you in a moment why we enable this. Now we need to make sure that we work with the proper color space in the V-Ray frame buffer as well. So open up VFB and make sure the layer panel is open. Select this display correction and change the color space from sRGB to OCIO. Next, you need to define that config.ocio file in this OCIO file path. Change the input color space to ACES CG. The display device is ACES and set the view transform to sRGB. So we are basically working and rendering in ACES, and the image will be displayed in the VFB in sRGB color space. Obviously, you can change the view transform to P3, for example, if your monitor supports it. And the last thing we need to do is to make sure that our textures and HDRIs are properly interpreted to work with ACES. So let's open up the material editor. You basically have three types of textures. Textures that control your color inputs, like your diffuse or reflection color. Textures that control the data inputs, like reflection glossiness or roughness, normal or bump inputs, displacement inputs. And finally, your HDRIs that you assign them to the environment for image-based lighting, for example. And for these three types of textures, you need to consider proper color spaces. There are two ways to achieve that in V-Ray. I'll show you both methods and you can decide which one is easier for you. So let's take this wood shader, for example, that is being applied to this backdrop geometry in the scene. The diffuse color of the material is being controlled by this parquet texture, and as it is a color input under the RGB color space section of the V-Ray bitmap node, change the color space to sRGB primaries. And color space transfer function can stay at from 3ds Max or sRGB, which is handled automatically by V-Ray, and you don't need to do it manually, but in case, check that out as well. You should treat all your color input textures like this one. For the data inputs, the RGB color space should be set to raw. For example, if I select this reflection roughness map, I have changed the RGB color space to raw already, and the color space transfer function is set to from 3ds Max as well. And the same thing is true for the bump map and the displacement map for this shader. Now, when it comes to normal maps like this one here, the RGB color space should be set to raw as well, but the transfer function should be set to none, as we don't want to apply any sort of gamma correction to our normal maps. Cool. I also have this V-Ray dome light in the scene that works as my only light source, and I have assigned an HDRI map through a V-Ray bitmap node to that dome light, as you can see here. For these types of HDRI maps, the color space should be set to sRGB primaries again, and the transfer function should be set to inverse gamma. V-Ray does that automatically whenever you load an HDRI map, so you don't need to worry about it. But again, just check it to make sure it works correctly. And that's it. Okay, now you are truly in ACES color space. So that is the first method. For our second method, instead of changing the RGB color spaces manually, you can include some predefined strings in your texture names that would make V-Ray interpret those textures automatically and assign the proper color spaces to them. And for this method to work, the auto RGB primaries for V-Ray bitmap texture in the render settings should be enabled. I have a duplicate of the same wood shader, and if I select the diffuse texture and take a look at its name, you noticed I have added an underscore sRGB at the end of the name. You can simply copy and paste your original texture on your storage and add that underscore sRGB to the end of that new texture's name. When you adjust your texture's name like this, you notice the RGB color space should be set to default, so you can add an underscore sRGB at the end of your color input textures, and that would make V-Ray to use the proper RGB color space automatically. And if I select the reflection roughness map, which is black and white data input, now I have added underscore raw to the end of its name, and the RGB color space is set to default again. Because V-Ray can render that texture properly, as we have added that underscore raw to the name of the texture. I have done the same thing for the rest of the data maps like bump, normal, and displacement map. Make sure to check the transfer function of the maps as well, so they are in from 3ds Max or sRGB, so the maps look correct. For the normal maps, obviously it should be set to none. Now, what should we do to our HDRI maps in this method? I have this second HDRI maps. You can rename your HDRI map and add an underscore len or underscore lin underscore sRGB. So underscore len underscore sRGB to the end of its name, and that should be all you need, which means this is a linear sRGB texture. Let me just show you the folder that contains these textures. So these are the original textures that I have used in the first method. You can see there is no underscore sRGB, underscore raw, or underscore len underscore sRGB at the end of their names. And in this folder, I have the same textures with the proper naming. You can see our diffuse texture has this underscore sRGB added to its name. Our data maps have an underscore raw added, and our HDRI has an underscore len underscore sRGB. So you can use any of these methods that you feel more comfortable with. It's up to you. If you forgot, you can always use this video and these textures here as a reference. Now, if I open up my frame buffer and start an IPR session, we should be in proper ACES color space. You notice it looks beautiful, more real, and easy on the eyes. Now let's apply the second wood shader to our backdrop geometry now. And as you can see, it looks identical to our first wood shader, even though we use the second method. The subject of color management and color science is a very deep topic which can't be covered in an introductory course. What I'm gonna do in this video is to give you an overall understanding of what ACES is and does. Then I give you a few examples comparing ACES and the default color manager and show you why ACES is just way better. And finally, I'll show you how to get your normal sRGB outputs out of an ACES color managed workflow. ACES is a system to manage color in all levels of the production, from the actual production and capturing to post-production and finally distribution. If you think of a typical CG workflow, you have different image data coming through in different color spaces like RAW, Rec 709, sRGB, log, and so on. You can get all these different color spaces and capturing formats into ACES using what's called IDT or Input Device Transforms. ACES manages and consolidates all of them using ACES CG color space. You work on your scene in the ACES CG color space. When you are done, you can render your scene out to any format, which is for us normally that should be sRGB with ODT or output device transform. Now, IDT or input device transform is just a fancy term for converting those incoming image data to ACES. If you have been following the course, that is the moment we select an image in our material editor and choose something like sRGB, RAW, and so on. Now, those image data are in ACES color space. While you are working on your render and when you are done with it, we can export our render to any output device like monitors using an ODT or output device transform, which simply put is the format or the color space you want to render your scene out with. So ACES CG is the exciting part for us. This is a large gamut linear gamma color space that is intended to be a working space for CG. I really invite you to read up on ACES if you are interested. There are tons of great articles on web explaining ACES painstakingly and can give you much more detailed info. In the ACES video in the introduction section, I showed you how to set up ACES in V-Ray. In the render setup window, under the settings tab, come down to the color management section and change the color space to ACES CG. It's a good idea to enable auto RGB primaries for V-Ray bitmaps as we learned in the ACES video back in the introduction section of the course. Then we need to load the proper OpenColor.io config file in the frame buffer. So open up the frame buffer. In the layer panel, select the display correction and change the color space from sRGB to OCIO. And then we can load the OCIO config file here. The input color space should be ACES CG because if you remember, we want to convert all the incoming image data to ACES and work in ACES while working on the scene and preparing for the final render. The display device is ACES and the view transform needs to be set depending on what you want to see, which is normally sRGB. And when we do that, we are basically using an ODT or output device transform to output from ACES to a color space that can be viewed properly, for example, on our monitors. Now we are basically working and rendering in ACES and the image will be displayed in the VFB in sRGB color space. Obviously, you can change the view transform to P3, for example, if your monitor supports it. Now let's talk about the advantages that we get from working in ACES. Let me open up this scene. 0603 underscore ACES underscore 01. And this is the same scene for the interior lighting lesson. The scene is set up with ACES, and if I quickly run the IPR, now this is the type of scene where ACES really shines. We have a lot of incoming light through the windows coming from the sun and the dome light. Because we are using ACES, we can keep increasing the intensity of our light sources to emit more light into the scene. And because of the way ACES handles highlights and overexposed areas in the render, we can keep emitting more light and energy into the scene, which would be impossible without ACES. Let me stop the IPR and show you the final render. Look at the ceiling areas close to the windows. They look very natural. There is no burnout pixels. It looks like a natural room. The blinds details can be seen easily within the highlights. Now let's open up this scene called ACES 01 sRGB. Now, this is the exact same scene, but it uses the default sRGB color space, which we can see it in the render settings and in the frame buffer. And this is the render that we get from this scene. You can immediately see a tangible advantage for using ACES. Because we are dealing with an interior scene and we need a lot of incoming light to make it natural and realistic. Now, how can we deal with this burnout highlights? The answer is simply ACES. The best way is ACES. There are other ways because it has a much wider color gamut. It can handle those overexposed highlights much better. If we compare this render with the previous ACES render, now in the first one we used ACES and in the second one we are using just the default color space. Just look at how much ACES is better in preserving those highlight details, primarily because ACES has such a filmic response curve. Now, if you are not using ACES for whatever reason and like to get a similar filmic response curve to be applied to your normal sRGB render, you can use a built-in frame buffer feature which allows you to apply such a curve to your normal renders. So let's take this sRGB render and add a filmic tone map correction layer. Now, as you can see, immediately it looks more similar to the ACES render. And to make it even closer, let me set the shoulder strength to around 0.02, linear strength to around 0.045, and toe strength to around 0.2. And now this looks very similar to our ACES render, but ACES does it for free. On top of that, it has other advantages as well. ACES naturally gives way more range to work with in post for archiving purposes and so on. We'll learn a few more as we go through this lesson. Now let's open up this ACES 02 scene and let's run the IPR. In this scene, we are dealing with an extreme scenario. You can see our light sources have these extreme saturated colors, some strong environment, fog, and so on. Let me stop the IPR and clear the image and show you the final render from this history panel. Notice how ACES handles all of these colors and lights pretty well. We get this nice color mix throughout the scene. There is no haloing, everything blends naturally. That shiny red back keeps its vibrant red color. Look how beautifully this lampshade reflects the lights. It's really hard to get a similar result outside of ACES. With extreme colors and lights, ACES works fabulously. It simply means ACES gives you way more creative range to explore. You can shower your scene with colors and lights and it will just work. Now, if we render this exact same scene in the default color space, this will be the result. And basically, this is the render from this 0603 ACES 02 sRGB scene. You can see it cannot handle all these extreme colors and lights. If I compare it to the ACES render again, you notice in the default render, the colors appear more washed up, color mixes fall apart. Take a look at this lampshade, for example, and you can see the problem obviously. And the darker pixels are less contrasty. It becomes obvious why ACES is clearly the superior color management solution when working in V-Ray. It has a much wider gamut and therefore it is capable of handling more incoming lights and saturated colors. Simply put, it's very good at preserving highlights, shadows, and colors. Now let's talk about exporting from ACES. So we have this render. Let's say we want to export it and get a normal sRGB, JPEG, or PNG out of it. First, you need to export it to EXR. So from the file menu, choose Save All Image Channels to a single file. Let's name it something like 0603_ACES, which is the name of this scene. And press the Save button. Now we have our EXR render properly saved. We can head into something like Fusion and see our ACES render and how we can manipulate it in post using Fusion. So here I am in Fusion. Let's drag in the render. And here is our render. To see the lens effects and the denoise render, let me change the RGB channel for this image to effects result RG and B. That's where V-Ray saves those effects. What we see right now is not what we saw in the frame buffer, and that is because we were using an output transform in the frame buffer to see the result in an sRGB color space. And that is when we change the view transform to sRGB in the frame buffer. And here we can do the same thing using an OpenIO color space node. So let's add one after our loader node. Now we need to load that same OCIO config file that we used in V-Ray. So add it. Now we need to define a source space and an output space. The source space was ACES CG, if you remember, that was our rendering color space back in V-Ray, and the output space is output sRGB. And now if we view this node, we should get the exact image that we saw in the frame buffer. Now we can go ahead and start color correcting the render, but the problem is we are in sRGB color space right now, and if we start grading, we'll lose all the benefits of working in ACES in post. So instead of converting the render to sRGB directly, we can convert the ACES CG render to ACES CC color space first, start grading, color correcting, and compositing our render, and after we are done, we can go from ACES CC to sRGB. ACES CC is another color space under ACES. It has a log gamma but is otherwise identical to ACES CG. It is intended as a working space for grading and compositing applications. Let me create a copy of my nodes and paste them down here and view the copied OCIO color space node. Now, the source space is ACES CG, right? But the output space is going to be ACES CC. As I mentioned, this color space has a log gamma. That's why it looks so flat right now. And now if we convert this from ACES CC to out sRGB, we should get the same result we had up here. So let me copy the OCIO color space again and set the previous node as the input. And let's view this node. Now the source space is ACES CC and the output space is output sRGB. Now we are back where we were, but now we can start color grading and post work between these two nodes because that's where the render is in ACES CC color space, which allows for a fully featured color grading in ACES. Let's make some space between these two nodes. I'm gonna press Shift and space and add a color correction node and hold down Shift and insert it between these two nodes. Now we can start grading the image and enjoy the benefits of ACES in the post level as well, including its realistic filmic response. I'm gonna increase the gain to around 1.15 and decrease gamma to 0.85 maybe. Cool. And when we are done, we can add a saver node at the end of the chain and render out our image in any format we want, like JPEG or PNG. And here is our final render. Now, if I get back to 3ds Max, in the frame buffer and under OCIO settings, you have this checkbox called Save in Image. What it does, it saves out the view transform with the image, and you don't have to do that conversion in ACES. But again, because you want to be able to color correct in ACES as well, you should probably keep this option disabled. But if I enable it and save out the image, again, let's name this one 0603 underscore ACES underscore 2. And head back to Fusion. Let's just drag in the new render and view it. And that's it. This image is already in sRGB color space and does not need any conversion. But for safekeeping, for archiving, for the wider ACES range in post, just save the render without save in image being enabled to get all the benefits of ACES in post. Now back to Max. If you are rendering a sequence and saving out the image using the available options in the render setup window, just save it out in 16 or 32-bit EXR and you should be good to go. So in this video, we learned about the ACES workflow in V-Ray for 3ds Max. See you in the next one. Make sure to visit our website mographplus.com or our Gumroad page at gumroad.com/mographplus and check out our premium CGI and rendering courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Redshift, Octane, and so on. See you in the next video.